Hello guys, welcome to Victor Science Hub. In today's video, we're talking about partial differentiation. Now, we have been used to this differentiation of the y over the x. In this differentiation, we differentiate a function with respect to one variable x. But in partial differentiation, we can have multiple variables, let's say x and y. So, and we use the symbol partial f over partial x to find the partial differentiation of x with respect to x, and partial f partial y to find the partial differentiation of f with respect to y. Suppose we have this function with variable x and y, and we are told to find partial f over partial x and partial f over partial y. For us to find this, so first we have partial f over partial f, partial f over partial x. Now, to find the partial derivative of f with respect to x, we'll look at y to be constant. That means y will be like a constant. So we differentiate with respect to x. Now, differentiating with respect to x here, we'll be having 6xy. Y is a constant. We are not going to touch this. What we are differentiating is only this. That is why we have 6, because differentiating x squared, we'll be having 2x. So that is, we will be having 3 into 2xy, which is 6xy. So that is how we had 6xy. And now differentiating this one, since there is no x, we are differentiating this one, and is a constant. Remember, y is a constant because we are differentiating with respect to x. We look at y as a constant. Now, when we differentiate it, we'll be having 0. So we'll be having 6xy. Now, the second one is partial f over partial y. We'll do the same for y. Now we are going to be keeping x to be the constant here. So since x is the constant, we are not going to touch x. We are just going to differentiate y. So if we differentiate y, we'll be having 3x squared. Differentiating y, we'll be having 1 plus differentiating y here, we'll be having 2 into 1. So 3x squared times 1, we'll be having 3x squared plus 2 times 1 is 2. So we have 3x squared plus 2. Now we have another question. We have this function has two variables, which are x and y. So we are looking for partial f over partial x and partial f over partial y. So now let's start with partial f over partial x. So partial f over partial x, looking at the function, remember, since we are differentiating with respect to x, we keep y to be constant. So now, keeping y to be constant, remember, this is chain rule in your normal differentiation. When we are differentiating this, we differentiate it using chain rule, where we differentiate the inner function and we differentiate the outer function. So let's say we are differentiating using chain rule. We'll just be differentiating what is inside here, and we'll now differentiate what is outside. So that is what we are going to apply here too. But in this case, we are going to be looking at this one to be constant. So now let's differentiate what is inside. Differentiating the inside function, we'll be having 3 into, differentiate x, we have 1, minus 0, differentiate y, we have 0. Now this is the inner function. This is the inner function. Now we now differentiate the outer function. Differentiating the outer function, we're going to be having 2 into 3x minus y, because we can call, let's call this function u. So it will now be looking like u square, and we'll now be differentiating u square, which is 2u, and u is this value. So that's how we got this. So the outer function is now 2 into 3x minus y. So our value is now 3 times 1 is 3, minus 0 is still 3, times 2 into 3x minus y, which is 6 into 3x minus y. So that's the value of partial f over partial x. So now for partial f over partial y, we still do the same thing. We look at x to be the constant and y to be the variable that we are looking for. So x is the constant. Now we will still use the same method. We differentiate the inner function and later differentiate the outer function. So differentiating the inner function, we differentiate x with respect to y. We differentiate here with respect to y. X is the constant. So we'll be having 3 into 0 minus 1. Differentiating y is 1 times the outer function. Differentiating it will be having 2 into 3x minus y. So this is going to be giving us 3 times 0 is 0. So we'll be having minus 1 times 2 into 3x minus y. So that will give us minus 2 into 3x minus y. So that is the value of partial f over partial y. So we have another problem here. In this case, we are having the function with 3 variables. So the first thing we are finding is partial f over partial r. Now we are differentiating the function with respect to r. So anything other than r is going to be a constant. So theta is a constant, psi is a constant. Here we see psi or theta is a constant since we are differentiating with respect to r. So differentiating this, sine theta is a constant here. So we have 4 into differentiating r square, we'll be having 2r sine theta plus this and this are constant. So we differentiate e raised to power r since it has r. So we have 5 e raised to power r is still the same as e raised to power r cos theta sine psi minus, we don't have r here and these are constant. So if we differentiate it, we'll be having 0. So this is going to be, this time this is 8r sine theta plus 5 exponential r cos theta sine psi. So this is our partial f over partial r. For partial f over partial theta, anything other than theta is a constant. So here this is a constant. So we differentiate sine theta. So we have 4r square. Differentiating sine theta, we'll be having cos theta plus this is also a constant. So we differentiate sine cos theta. So we have 5 e raised to power r. Differentiating cos theta, we'll be having minus sine theta times sine psi minus. Now we don't have theta here, so we differentiating this will be having 0. So we'll now be left with 4r square cos theta plus okay, this minus will multiply this, so we're having minus 5 e raised to the power r sine theta sine psi. So the last one, which is partial f partial psi, is equal to, now anything other than psi is a constant, so this and this are constant. So if we differentiate this, we're going to be having 0. So 4 into 0 times 0 plus, we have psi here. So these are constant. So we're having 5 e raised to the power r cos theta. Differentiating sine psi, we'll be having cos psi minus, here we have psi. So we have 2 into, differentiating cos psi, we'll be having minus sine psi. So this is equal to, this times 0 times 4 is 0 plus 5 exponential r cos theta cos psi. My, this times this will give us plus 2 sine psi. So partial f partial psi is equal to 5 exponential r cos theta cos psi plus 2 sine psi. So that's the value of partial f over partial psi. So that's it for this video. Please don't forget to like, share, and subscribe. I'll see you in my next one. Thank you for watching.